Today's lesson's on solving radical equations. Here's your steps to solving radical equations. You're going to need to write these down and use them to help solve these problems. Let's look at the first problem. 3 equals the square root of x. So we want to get rid of the square root. The opposite of square root, or the inverse of square root, is squared. When we do something to one side, we have to do it to both sides. So if we square the right side, we have to square the left side. 3 squared is 9. The square root of x squared, remember the square and the square root cancel out, so we're just left with x. So x equals 9. Now, we definitely need to check our answers here. So we're going to take 9 and substitute back in for x, and the square root of 9 is 3. That's a true statement, so x equals 9 is the correct answer. Not all the time will these answers check out to give us a true statement. Go back to your steps. I think our steps said we needed to isolate the square root, or the radical. In this case, it is the square root. So we have minus 4. We need to get rid of the minus 4. How? Plus 4. 5 plus 4 is 9 equals the square root of x. Now we need to get rid of the square root. How do we do that? Opposite, or the inverse of square root, is square. So we're going to square both sides. 9 squared is 81. And the square root of x squared is x. So we have x equals 81 is our answer. Now we're going to go back and check. And we're going to take 81 and substitute in for x. Square root of 81 is 9. 9 minus 5 is 5. And we have a true statement. So x equals 81 is the correct answer. Number 3. The square root is isolated. So our first step is going to be square root both sides. 5 squared is 25. And the square root and the square cancel out, so we're left with x plus 4. Now we need to solve by subtracting 4. 25 minus 4 is 21. Now don't forget to check. We're going to check by taking 21 and substituting it for x. We get 21 plus 4 is 25. Square root of 25 is 5. We have a true statement. So x equals 21 is our correct answer. Notice in problem 4 is the square root isolated. No, it's not. So we need to isolate it first by adding 2. Now we have it isolated. We want to get rid of the square root by squaring. So we're left with the x plus 1 equals 36. Now we're going to solve for x. Subtract 1. And we get x equals 35. We got to remember to check. We're going to check by substituting 35 for x. 35 plus 1 is 36. Square root of 36 is 6. 6 minus 2 is 4. And 4 equals 4, so we have a true statement. So x equals 35 is the correct answer. Now, number 5 has the cube root. We still need to isolate the cube root. It's already isolated, so the inverse of cube root is cubing. So we're going to cube both sides. Cube and cube root cancel out. We have 5x plus 2. 3 cubed is 27. Solve for x. We have 5x equals 25. Divide by 5. X equals 5. Remember to check. We're going to check by substituting 5 in for X. 5 times 5 is 25, plus 2 is 27. Cube root of 27 is 3. 3 does equal 3. We have a true statement. X equals 5 is the correct answer. Number 6. Square root is not isolated, so we got to get rid of the 5. The 5 is plus. Remember, we look in front, not behind. So we're going to subtract 5. Left with square root of 4x minus 5 equals 7. We have the square root isolated now, so we're going to square root both sides. 4x minus 5 equals 49. Add 5 to both sides. 4x equals 54. X equals 13.5. We got a decimal here. Is that okay? Yes, it is. But we need to check. So we're going to check by taking 13.5 and substituting in for my X. 4 times 13.5 is 54. Subtract 5 is 49. Square root of 49 is 7. 5 plus 7 is 12. 12 does equal 12, so we have a true statement. So X equals 13.5 is the correct answer. Look at number 7. Is the square root isolated? No, it's not. Here we have 5 times. So to get rid of the 5, we need to divide by 5. Square root of 8x is 4. We have the square root isolated now. So we're going to square it. 8x equals 16. I'm going to divide by 8. X equals 2. Don't forget to check. Substitute 2 in for X. 8 times 2 is 16. Square root of 16 is 4. 4 times 5 is 20. 20 equals 20 is true statement. X equals 2 is a correct answer. Now let's look at number 8. A little tricky here. We have 6 minus. Square root is not isolated, so we need to get rid of the 6. Remember to look in front. That's a plus 6, so we need to subtract 6 from both sides. Don't forget to bring that negative down. Now we have what number here? Negative 1. How do we get rid of that negative 1? Well, that's negative 1 times, so we need to divide by negative 1. Now we have square root isolated. We're going to square both sides. 3x plus 9 equals 36. Subtract 9. 3x equals 27. Divide by 3. X equals 9. Now we need to remember to check. So we're going to substitute in 9 for X. 3 times 9 is 27, plus 9 is 36. Square root of 36 is 6. 6 minus 6 is 0. 0 does not equal 12. So we have a false answer. So here we have no solution. See, it's important to check here. If you didn't check, you would have thought x equals 9. Let's look at number 9 here. Looks like we can't do it. Why? Because we have a rational exponent. We don't like that. So what if we change the rational exponent to a radical? We would have the square root of 9, or square root of a. Remember, we have the base, it's the radicand. Numerator is the exponent. Denominator is my index. Plus 9 stays outside. We do not have the radical isolated, so we're going to isolate it. Square root of a equals negative 9. We have it isolated now, so we're going to square both sides. Remember, when we're squaring here, we need to put that negative 9 in parentheses. And we have a equals 81. Again, we need to check. We're going to go all the way back up to our original problem here. So we have 81 to the 1/2 power plus 9 equals 0. 81 to the 1/2 power is 9. 9 plus 9 is 18. Here we don't have a true statement. We have a false statement. So again, we have no solution. Let's look at number 10. Don't like that rational exponent, so we're going to change it. 6n minus 5 is my base. 1 is the exponent, and I don't need to write it. We got square root. Plus 3 is outside the square root. I'm going to isolate square root. We have it isolated, so now we're going to square both sides. Negative 5 squared is 25 equals 6n minus 5. We're going to add 5. 6n equals 30. 5 by 6. N equals 5. Now we need to check. I'm going to check by substitute in 5 for n in our original equation. Six times 5 is 30, minus 5 is 25. 25 to the 1/2 power is 5. 5 plus 3 is 8. 8 does not equal 2, so we have no solution. Again. Let's look at number 11. What do we notice? We have square root on both sides. So they both isolated? Yes, they are. So how do we get rid of it? We just square both sides. We have x minus 5 equals 2x minus 4. Now we're going to solve for x. First thing I'm going to do is subtract x. These x's cancel. Negative 5 equals x minus 4. Add 4. Negative 1. So x equals negative 1. I'm going to make sure I'm checking. Negative 1 minus 5 is negative 6. Square root of negative 6, that's not a real number. So right there we know we have no solution. Number 12, now we got cube roots, but we notice the cube root on both sides are isolated. So all we do is cube both sides. We have 2y minus 7 equals y plus 2. Now let's solve for y. Have y minus 7 equals positive 2. Add 7. And I get y equals 9. We're going to make sure we check again. Substitute in 9 for our y. We have 2 times 9 is 18 minus 7, cube root of 11. 9 plus 2 is 11, so we have the cube root of 11. Cube root of 11 equals the cube root of 11. So our answer is y equals 9. Here's some problems for you to try and turn in.